In today's video, I'm going to be looking at flat slab design. Before we talk about flat slab, let's briefly explain the different type of slabs that we have. In constructions, we have four basic types of slab. We have the solid slab, which comprises of beams and slab. So in the load distribution mechanism, the load is distributed from the slab to the beam, then to the column, and then to the foundation in a typical solid slab. So solid slab you can have two-way slab, you can have one-way slab, and in some other cases you can also have cantilever slab. Then the other type of slab is the waffle slab. This kind of slab are used for longer span, and they are basically used in public buildings with longer span and high live load. So this waffle slab is just a little bit different from the rib slab, in terms of the rib slab is in one direction, but waffle slab is in two directions. Then the waffle slab can be formed with different kind of materials to form the waffle. So sometimes you can have pots, and in some other cases we can make use of normal bricks to create the waffle and also to leave the void in the area. So you can have waffle with void and waffle without void. Then the third type of slab is the flat slab, which is what we are going to be discussing in this video. Then we also have the last one, which is the rib slab. You can see that the difference between waffle and rib slab is waffle is the has rib in both directions, while rib slab has rib in one direction. So both of these slab are used for longer span. I mean the waffle slab and the rib slab. So talking about flat slab are slabs in which the load distribution mechanism starts from the slab, and in this case there's no beam. So you have from slab to column, then to the foundation. So that's how the load distribution mechanism goes. So flat slab can occurs in four kind of situations. So you can have the normal flat slab, where you just have flat slab supported by columns, but most of the time this kind of connections is much more uneconomical, because you have a lot of the thickness of the slab, which tends to be much more thicker. So in order to reduce the thickness of the slab, you can have the remaining three situations, where you have flat slab with draw panels. That is, you provide draw panels in area where there is tendency for punching shear effect on the slab, that is at the location of the columns. Then you can also have flat slab with column head. So this is an example of column head. So column head is much more smaller compared to the draw panels. Then in some other configuration, you can have connection of both draw panels and column head. So flat slab can take four arrangement. You can have normal flat slab with column. This one requires a much more thicker slab. Then you can have flat slab with draw panels. Then you can have flat slab with column head, as well as flat slab with draw panels and column head. So flat slab are used, they have a lot of advantage in construction. So one of them is low cost of formwork. So in this case, you don't need to provide formwork for your beam, because there's no beam. You only have to provide formworks for your column and the slab to support the column and the slab. So it reduces the cost of formwork. Then it also provides some aesthetics, because in this case there's no beam, so all you just have is column and slab. So in some forms it's much more aesthetic compared to a solid slab that has beam. Then some of the disadvantages: flat slab requires a number of technicality in terms of construction, so it is not a common construction that we see most of the time. Much more technicality is involved compared to a normal column, beam and slab construction. In today's video, we are going to be looking at the design of a typical flat slab, like of this kind of connection. So in this slab we have about 4 panels, and each of the panels is 4 meters by 4.8 meters from grid line to grid line. The size of the column, we can take the size to be 230 by 230 for now. Then assume a slab thickness of 200 millimeters, and this value here is the level of the slab. So we are going to be using the Tekla Tedds for the design of this. All we just have to do is to input our parameters into the software. So let me open Tekla Tedds and then we start the design. For those of you that are not familiar with this software is an amazing calculation template. You have a series of calculations you can do with this software. So I've already made an introductory video on Tekla Tedds. You can check out the link in the top right corner of this video. You can check the description below to get the introduction to Tekla Tedds. Then also, if this is your first time on my channel, in this channel we talk about civil engineering design, highway design, structural design. So you can consider subscribing to the channel so that whenever I make any interesting video like this, you get to watch them first. And also please subscribe to the channel, because your subscription is also what encourages me to make much more content. Please, let's get this channel to get to 500,000 subscribers. So the first thing you have to do with Tekla Tedds is you first of all need to set your design standard. So basically, I personally make use of the UK standard, or I either use the European standard. So you come under the local, then you set your standard. So you only have 6 countries here, but you know, in most of the standard we can have, like the European standard is used across Europe and it's also acceptable in some part of Africa. The same thing to the UK. So I'm just going to stick with the UK standard. Then another thing is you can set a lot of things. So these are some of the things that I've talked about in the introduction to Tekla Tedds. You can check out that video. Then the first thing you have to do now to set your project is to click on new. So once you click on new, then you can now find a design template that resembles what you want to design. So in this course we want to design a floor, so we go to floor. Then we want to design RC flat slab design. So you look for RC flat slab design. As you can see, you can design a lot of things. You can analyze beam, column, you can design composite structures, composite beam, you can make connection design and all of that. So I'm just going to click on RC flat slab design. Then here you are going to see the scope in which the design is based on. You can see that the analysis is based on using the yield line theory. Then you can see notes, assumptions that were made, and also the references. So you must make sure that your assumptions correlate with what you have, so that it will be able to work perfectly with the code. You can see that the flat slab is assumed to be supported on a regular grid of columns. That is, you have assumed that you have column grid with the same size, maybe along the x and along the y. They are not they do not differ. And then the span of the slab is assumed to be approximately equals to both the x and y direction. I hope you understand. So approximately equal, so their difference should not be much. So you must just read all these assumptions and limitations for you to be able to know if what you want to design fit into this design template. So what I'm just going to do is I'm going to click on calculate. So after clicking on calculate, the software is going to load the template for you so that you can input your parameters. So the first thing you have to input is the slab geometry. So from the layout that we have here, along the x-axis, the spacing of the columns, or let's say the span. So this panel 1 is a span, this panel 2 is another span, this is another span, this is another span. So this is 4.8, this is 4.8 meters, and then along the y direction the spans are 4 by 4 meters each. You know, from the assumptions that we first of all check, you see that the span must be approximately the same. So that is why this layout will work. So you have to input the span of each bay in x direction. In x direction is 4,800 millimeters. In y direction it is 4000. Then the next thing is the size of your columns. From this our layout, both the internal column and the external column have the same size, which is 230 by 230. So I'm just going to input the size of my column here, 230 by 230. Then the next thing is the size of the external column, which is the same thing, 230 by 230. Depending on how the layout is, so the sizing of the column changes. Then the next thing you have to input is the details of the slab itself. So the first of them is the depth of the slab. So the depth of this slab is 200 millimeters from the layout. Then the next thing is cover to reinforcement. For slab, we can put a cover of 25 mm or 20 mm, or in this case I'm going to use 25 for both top and bottom. Then the next one is the default reinforcement. So this is a flat slab, so I'm going to go with 16 mm bar, though this might not be economical, but let's just stick with 16 mm for the main reinforcement. Then for the primary reinforcement, let's go with 12. So if any of these terms you did not really understand what they are saying, you can highlight your mouse on this icon with an eye, so it's going to give you the definition of each of these terms so that you can understand it. Then you click on next. So the next thing is the material details. So for concrete, you are going to make use of 25. So let's say what you want to input is not here, you can just type in, let's say I want to put 15, so you can put in 15. You can put anything that is not in the drop down. So then the characteristic strength of main reinforcement, so I'm going to go with 410. So my parameter is not given, so I just input. The same thing for the shear reinforcement, I'm using the same strength for the main and shear. The material safety is going to be 1.15 according to BS 8110. So for my characteristic dead load, this includes the self weight of the slab, so I'm just going to put 7 kilonewton per meter square to include self weight services and other dead load. For the live load, I'm going to go with 1.5 because we know flat slab does not really take much live load, because I assume this is an residential building. Then we have dead load factor, which is 1.4 according to the code, and live load factor is also 1.6 according to the code. Then you have a moment distribution of 10%, so that's why this B is 1.1. Then you also leave this ratio of support, you can leave it to 1, or you can just click on this icon to read about it. Then you click on next. The next thing is your design requirements. So you have to include punching check, because this is the important check in design for flat slab. Then you also include the containment of your reinforcement, that is, you want the software to give you a sample of how the detailing is going to look like. Then you click on next, allow it to calculate. So the calculation is done now. Then you can now check your design parameters before you proceed to extracting the PDF file of the calculation sheet. So the first of them is X direction. So the software is going to check for sagging moment along the X and Y. You can see the percentage of reinforcement. This is 0.9%. You can go back and try to reduce it. You can see it's providing 16 mm at 2225 at the penultimate columns. Then for columns, the internal columns is providing 16 mm by 300. Then for the sagging moment, it does the same thing. So most of them 16 mm by 225 works for them. So then you can also check for punching shear. So if there is if the shear reinforcement is required, it's going to input that. But from this summary calculation, it's not giving us if the punching shear is satisfactory or not. But let's just go to next. This is now the tab for the output requirement. Like, do you want a perspective drawing? In this case, this drawing is just a sketch on how your slab is supposed to look like, because you know this template is for slab that have approximately the same span. So therefore there is going to be a perspective drawing, like you are cutting a section. Then the level of required output, how detailed do you want your calculations to be? Do you want the full detail, or you just want the summary, or you don't even want to see any calculation, you just want to see the drawing and the reinforcement? So in my own case, I will select full calculation. Then I also want it to include a reinforcement drawing, so I'm going to check this. So all you have to do now is just to click on finish. Once you do that, the software is going to load, and then you can see the calculation sheet. So the first thing is slab geometry, just like we inputted. Then you can see the perspective drawing. So this is just a drawing trying to show how the flat slab configuration is. Then you can now go through the design step by step. This is the design along the x-axis. Check for the sagging moment. You can see there's no need for compression reinforcement. Definitely most of them pass. You can see the deflection along the span to depth ratio is okay. You can also check for the y-axis as well. So I'm just concerned about checking for the punching effect. So let's come to punching check. This is the punching shear checks. You can see the design shear stress and the maximum allowable stress. You can see this is lower than this, so therefore the maximum concrete shear stress is not exceeded at the column perimeter, so therefore it passed the punching checks. So they do the same thing for internal columns and columns at the middle. You can see all of them passed the check for punching shear, because this is shear at 1.5D according to the BS 8110. So you can just scroll down. This is your calculation sheet. Then the software also give you a sample reinforcement detail. We said it should include it, so you can see the reinforcement detailing, though this might not be so detailed, but to some extent it's nice. And then you have your summary of your reinforcement. So the next thing you want to do now is you want to convert this calculation sheet into PDFs. But sometimes you might want to make some editing and all of that. So in Tekla Tedds, what you can do is you can convert it to Word document, and then from there you convert it to a PDF, or you can even copy it and go and copy and paste it in a text file. So what I'm just going to do is I'm going to click on send to. If you want to learn how to edit all these headers to include your name, the date, check by, and all of that, check out my first video on introduction to Tekla Tedds. You are going to see that there. Then you just have to do is click on send to. Once you click on this send to, then you can select any of these. You can select Microsoft Word, you can select text for words, you can attach it to an email to someone, you can save it as other files. So if you click other files, probably it's going to save it as .rft, so but we don't want that. So just select Microsoft Word and you click on next. So it's going to load it on Microsoft Word. So then you have to select, do you want it to open in a new document, or you have an already open document that you want to attach it to. So I'll just go with open a new document, and I will leave it blank. I will save it later. So just click on next and click on finish. So this is going to load the Microsoft Word package, and then you can see your calculations. So this is the calculation sheet. You can see the perspective drawing. Then scroll down to see all the calculations for both x direction, y direction, and also check for punching shear. So since everything has been extracted, you can easily print this and convert it to PDF, and then attach it to any drawing you want to attach it to as a calculation sheet. So this is what I want to show you in design of flat slab using Tekla Tedds. If you find the video helpful, kindly hit the subscribe button, turn on the notification. That is very important. Make sure you turn on the notification so that when next I make amazing video on civil engineering, you'll be the first to watch them. Thank you. And also, we wanted to make this channel to get to 5,000 subscribers. Please kindly subscribe and share with your friends. See you next time.